conference will now be recorded.
Good morning. If I could invite everybody to go ahead and grab your last beverage and come on in and take a seat as we're going to kick off this morning's plenary session before we then go into the rest of our day's breakouts. So welcome everybody. Uh, Thanks for coming back. It's always good to see energetic, excited faces, especially after what is often an interesting tour of a new location after the first day of the meeting, where we don't have things like receptions and other things going on. So there's a lot of exploring, and sometimes that results in late nights and early waking that is sometimes a little difficult. So I appreciate your presence here at 8 o'clock in the morning. Um, Hopefully yesterday you had a chance to go to some of the sessions and both see see some new ideas and concepts, and also engage in probably some things that you've been connected to for quite a while. As that is the pattern we encourage here, is new experiences and also connecting with long-standing activities. Um, and the connections with activities go beyond the boundaries of ESIP. And this is where, as we focused yesterday, there was a lot of emphasis on sort of building out in terms of the structure and organization of our organization to create an understanding of what our community looks like. But another key role for the members of the ESIP community is to help us connect with other like-minded organizations around the U.S. and around the world. And this is where ESIP has had a lot of success in connecting to other organizations where we have overlapping interests and concerns, where we can actually amplify the values and priorities of ESIP by being able to experience even greater economies of scale in shared activities. That includes our work with AGU and EarthCube and other largely U.S. national organizations, but also international organizations like the Group on Earth Observation, or GEO. The work that we've been doing with the Geo Value Group in helping to develop strategies and approaches for being able to demonstrate the value of geospatial and Earth observation data and information. Our work with RDA and the many connections from the ESIP community into the global activities of the Research Data Alliance, and our increasing connectivity with other national or regional organizations like the Australian Research Data Commons, and the formation of the E2SIP organization in Australia, where we've been able to help incubate and infuse some of the ideas and approaches that ESIP has found so successful, and also again establish communication and sharing beyond the boundaries of ESIP. And this all happens because of the community, the connections that we have as individuals with these other organizations and activities. So we rely upon all of you and all of us to continue as we're interacting in other activities to keep an eye out for synergies between what you see ESIP is doing and what you see other organizations are doing, and helping us to identify where those opportunities are for shared activities. Of course, my notes just went away. So I'd like to invite Shana to come up to provide a brief introduction to one of our events coming up.
Good morning. I'm Shana Skolnick. You all know me best from NASA and Navteca. But last summer I had pitched at the Funding Friday an idea for Climate Warrior virtual reality experience, which you all supported. And that has now also morphed into a fashion show. So tonight I'll be showing some of the VR pieces that I created called Climate Fables. And then on Thursday, we're going to be having our first ever ESIP Climate Warrior fashion show, not to show new fashions, but to show things that are eco-friendly. So the idea is you'll see things that are thrifted, upcycled, recycled, consignment, hand-me-down, which I'm sure many of you already are doing, but the idea is to get the word out that these are things that we can do every day to take small actions that support climate awareness. So many of you have already volunteered. If you would like to volunteer still to be in it, we're happy to have you. So just see me at some point. And that will be on Thursday at the very end of the on-conference session at 5 o'clock. So hopefully we'll see you here for a fun event. And do Fundraising Friday, because that's fun too.
Excellent. And and this event is a good opportunity for us to continue to try to identify opportunities to sort of walk the walk of as we talk about data to action. One of the key underlying themes for action is action in support of trying to figure out strategies for mitigating and reducing our impacts when it comes to climate change. And while we still have an ongoing challenge in terms of the incredible value that we find in our face-to-face meetings and recognizing the carbon footprint that a face-to-face meeting has, being able to take what measures we can to try to balance that by doing things like reducing the swag and other materials, the printed materials, trying to at least nibble away at the edges of that impact is an important value for us that we continue to try to move forward. I also have a couple of reminders and announcements that I wanted to make before we go into this morning's plenary talks. The first is the importance in all of the sessions to go ahead and record the takeaway items that are coming out of your sessions and do them now. Do them while they're fresh, while you're here and you're engaged in the energy and activity that you've completed as a part of those activities. This is a key part of both documenting for ourselves and for future participants in our different collaboration areas. So please take the time right after your session to maybe sit down with your co-leads in the session or other participants to make sure that that information is captured, because this is also going to be a part of the record that is going to go into Figshare. As we talked about yesterday, the preservation aspect of the content that's being developed and being able to take what could be going into a slightly more ephemeral environment, the sketch system, being able to bake that out into a document that's going to go into a long-term repository so that we have better access to our own history, but others who are perhaps coming new into ESIP can also have a point of access for information about what has come before. The other thing I wanted to ask everybody to start thinking about and to be prepared to do tonight is we have a number of interactive components associated with tonight's reception. One of the ongoing activities that we have in ESIP is actually being able to more directly define linkages and connections between the diverse activities that are going on within ESIP, within our collaboration areas, and our strategic goals that we've been working towards over the last 4+ years. And so as a part of the reception tonight and in exchange for your drink tickets, we're asking you to help us explicitly link the activities you've been working on in your collaboration areas to our strategic goals. And that'll be one activity. And then we're also having another opportunity to essentially leverage the brain trust that is ESIP as we are working on trying to collect and compile a set of data steward skills that can then feed into a number of activities, including the development of a collaborative roadmap of skills that can be made available to others as they're trying to figure out how they can perhaps aspire to become data professionals. So with that, I think we're ready to go ahead and start our plenary presentations. I'm going to go ahead and invite Kirsten Leonard from the Lamont Doherty Earth Observatory at Columbia University to introduce our next speaker.
Thank you. Sorry that I need to bring my computer, but the hotel room didn't have a notepad. So it is my absolute pleasure to introduce for this meeting Adam Menzer from the Smithsonian Institution to give the first keynote of this day. Many of you are familiar with the Smithsonian Institution and what a tremendous resource for research and education the collections at the Smithsonian Institution are. And Adam oversees the data for these collections. He makes sure that the data of the collections, the database is accurate and complete and so on, doing data cleanup. But he has also done a lot to make these collections more visible and more accessible to the broader audience. And this is actually how Adam and I started interacting when he wanted to register the collections with IGSN at the System for Earth Sample Registration. And we managed to work on web services together that allowed him to register 350,000 rock and mineral specimens in the IGSN system. So that was a fantastic achievement. Adam's background is in the earth sciences, and I communicated with him just a couple of days ago about his background and so on, and just reading in his email, he said, yeah, I did my master's with Roberta Rudnick at the University of Maryland on rocks, mantle or lower crustal xenoliths of Tanzania. I said, those are great rocks, and I really want to make sure that these rocks become part of the national collections. Showed the passion for the topic of specimens, and I can more than relate to that, where I have this passion for natural history collections as well. So Adam came to the Smithsonian in 2010 after a brief detour into the commercial world at ProQuest, I think it was. And he wrote that over the last 9 years, he has been quietly plugging along and trying to figure out how to get data about the collections out to the widest audiences. And I think he's on a really good path. And I'm excited to listen to his talk now on increasing the impact of the Smithsonian's geological collections. Adam.
Okay. Well, thank you for that introduction, and thank you, ESIP, for inviting me. So as Kirsten said, I work in the Department of Mineral Sciences at the Smithsonian, and I'm going to talk to you specifically about our geoscience collections today. So my background is in petrology and geochemistry, and I know this audience extends far beyond that, so I'll do my best to provide context as I go. So in these days of models and drones and world-spanning satellite imagery, it's easy to forget about the humble rock, but there's still a lot of really great specimen research going on. It's there to provide constraints for your models, to ground truth your satellite observations, but it's also there to provide new insights about the ancient Earth. And as laboratory methods and analytical instruments get more and more sensitive, even carefully studied rocks can provide new information. As just one example in this 2015 paper about meteorites from the Smithsonian's collections. But as a historical collection, it has its own challenges in terms of data. And so I'm going to talk to you today about what we're doing to make sure that our specimens are being put out in the best possible light. So I'll start with a whirlwind tour of the Smithsonian. Pictured here is James Smithson. He's actually a British scientist who left both the seed money and his name to the institution, as well as our mission statement, which is the increase and diffusion of knowledge, which isn't bad as these things go. Smithson was, among other things, a mineralogist. The mineral smithsonite is named after him. And he left his mineral collection to the Smithsonian when he made his bequest, although unfortunately it was lost in a fire in 1865. But the institution recovered, and the Smithsonian today has expanded from a single building, the castle, which is pictured at the bottom of this image, to a suite of museums, including 19 separate institutions, which combined welcome more than 28 million visitors per year. The building I work in is at the top of this image, the Natural History Building. It's been known for a lot of names over its life, but it's a really great museum. I was originally supposed to give this talk at the winter meeting. That didn't happen for some reason. It's kind of a blur. But if you're ever in DC, I'd highly encourage you to visit the museum if you haven't been, or even if you have. I understand that the dinosaurs are back. But the Smithsonian is and has always been an active research center, both in terms of performing its own research and enabling research elsewhere. And a fundamental part of this is its collections. And the scale of these sometimes surprises people. As a whole, the Smithsonian manages more than 155 million objects. The natural history collections alone are 146 million of those. It's one of the most extensive natural history collections in the world, with literally millions of striking objects, some of which you can see right now. So let's talk a little bit more about those collections. So the collections include specimens from the fields of biology, geology, and anthropology. The biology collections, which include plants, vertebrates, invertebrates, and bugs, make up about 78% of the collection, with the geosciences collections making up most of the last 30%. Almost all of the geosciences collections are paleobiology. But I'm not going to talk about the paleobiology collections. I don't work at that department. I did include a Tyrannosaur tooth in this picture, though. I'm going to talk about mineral sciences collections, which, yes, they make up a pretty small piece of this pie, but 500,000 specimens is a quite large for an earth science specimen collection. The mineral sciences collections are divided into three major divisions: the rock collection, the gem and mineral collection, and the meteorite collection, each of which is managed separately. The current collection is almost 150 years old now in its modern incarnation. Most of it was originally cataloged in handwritten ledgers like this one. In addition to material collected by Smithsonian scientists, it grows through transfers from other government agencies, especially the USGS, and from donations from private scientists, or private collectors and scientists. Growth of the collection needs to strike a pretty careful balance between historical interest, current research interest, and some sort of projection of what the future research interest will be. That's pretty tricky to do. But it's especially important in this time when so many institutions are sort of divesting or getting rid of their geoscience collections. All right, so the theme of this meeting is value, how to measure it, how to increase it, how to convey it. So I'm going to talk a little bit about how we construe the value of a collection. Natural history collection has two major functions. One is to educate the public about the natural world. One is the other, more important for me, is going to be to support research. And so here are three key ways that a collection can be used to support research. The first is to retain specimens that underpin significant findings. The The second is to provide access to unique or difficult to access specimens. This could be seafloor rocks, they could be rocks from space, it could be something as simple as a mine that's no longer accessible because it's been paved over. But one of the most important things the collection does is it allows researchers to build on existing work. So instead of starting from scratch each time, the researcher can start by focusing on the analysis or the work that they were interested in doing based on an already well-characterized sample. To support research, the Smithsonian makes loans of specimens to qualified researchers around the world with the expectation that when the research is complete, the researchers will furnish us a copy of their data and results. So for us, value is use of the collection. But that only really works if the collection is in active use. That means that scientists are requesting material, and it means that they're publishing on it. So based on that idea, here are some general goals for increasing impact of the collection. And this is all really simple. It's exactly what you'd expect. We want people to use the collection more. We want them to tap into our data as much as possible. This is a much bigger deal on the biology side for reasons I'll get to in a minute. But it's important for the geosciences as well. And finally, we want to refine the metrics that we're using to assess impact, both so we know what our audience wants and so we can guide decisions about the collection going forward. This is a map of our audience by country for roughly 3,500 loans that we've sent out in the last 20 years or so. Almost all of our audience is American, so that's 70 to 80% of it, with most of the international audience consisting of Western Europe, Canada, and Australia. This is the same plot, except showing the number of loans, and so we typically move between 100 and 200 loans per year. A significant fraction of these are from a single collection, our reference standard collection. So this is the same plot, except it's just showing loans in the rock collection. And the purple bar is our reference standard collection. This mostly consists of material from the Smithsonian microbeam standards, which can be used to calibrate instruments in labs. So that's a very big community need, but it's a little bit different than the normal goal of a loan from the collection. So I did just want to flag that that does make up a significant amount of our traffic. And for what it's worth, these numbers have been fairly consistent over time. The lines in pink on the left of the diagram, all that pre-2000 data, were compiled based on digitized transaction paperwork. And so these two data sets are not exactly comparable for reasons that I'm not going to get into, but the general idea is that the activity in the collection has been fairly level over time. So we're sort of in line with historical norms, but we're not making huge strides either. Now I want to talk a little bit about publications, which is a trickier problem. We could build all those plots from our internal transaction database, but for publications, we need to be able to either trust that our researchers are providing us copies of their paper reliably and that that information is being logged. We need to access that information separately. I'll tell you that first thing doesn't always happen. Researchers don't always fulfill the terms of their loan agreements. So it's difficult to keep exact track of how the collection is being used. To try to get some sense of those numbers, I've turned to a couple of resources that you can use to mine data from the geologic literature. The first is GeoDeepDive, which has a corpus of about 10 million documents, including recent research, which you can mine but not view. And the second that I looked at was the Biodiversity Heritage Library, which is partially run by the Smithsonian Libraries. And that has a much smaller corpus, but it does allow you to view the documents, and it does include the Smithsonian's own publications. It turns out the BHL corpus isn't really recent enough to be useful, so all the following is based on GeoDeepDive. So mining specimen numbers in the literature is a tricky proposition. Specimen numbers don't tend to be unique enough to do this, but catalog numbers are probably okay. They have a fairly distinctive form, which you can see at the blue box at the bottom of this slide. In our case, we have a 4-character prefix, which is either USNM or NMNH, and then it's followed by usually a 4 to 7-digit number. And that's consistent actually across the entire museum, and there's overlapping catalog ranges, which we'll have to deal with. but it's a fairly recognizable catalog number format. So the first thing we do is we look for documents containing one of those two prefixes. We then parse out substrings that look like catalog numbers. And this is the important step. We then verify those numbers as best we can against the specimens database. So in this case, we're looking at the terms in italics, which are garnet and olivine, match against the specimen records that match these two catalog numbers. So we can feel fairly confident that this isn't a fish. And that is an important distinction to make because there's way more literature about the other collections than there is about the mineral sciences collection. If we do that over the full Geo Deep Dive corpus, these numbers are from this month, we get between 15 and 30 publications a year. Is that a lot? I'm not sure. But the numbers, like the loans, are relatively flat. They likely underestimate the true number of publications, both because the Geo Deep Dive corpus is extensive but not exhaustive. It's a really great service. I like it a lot. But it's missing in particular a couple of journals that I think our scientists that work at the collection tend to publish in. But also because scientists aren't always citing the samples properly. So even if they're using them, we can't necessarily find them. And we'll never be able to find them. But this is an okay baseline, and it's something we can hopefully refine a bit over time. So our current impact, researchers in the US receive 70–80% of our loans. Publications and loans are more or less steady over time, and reference standards are a big fraction of the material that we send out. Now we want to talk about increasing impact, since we have some kind of baseline to work from. So this diagram shows some of the organizations and tools that we might use to try to get information about the collection out there. I'll say that we're still primarily in the discovery and accessibility phase. We want people to be able to find our specimens. We're not necessarily to the point where we've gotten things to be interoperable or reusable. So starting from the right side of this diagram, the blue boxes, like the Global Volcanism Program, those are internal Smithsonian initiatives that we share data with. At the bottom are some geoscience specimen catalogs that offer searches that span multiple collections. And on the left are publications and data derived from publications. That includes the databases managed by EarthChem, which pull chemical analyses from the literature, and the Meteorite Bulletin database, which logs information about the known finds and falls of meteorites. And in the middle of the document are the TADWIG standards. TADWIG is a biocollections information standard group. They're very big in the museum world. They primarily work with biodiversity or biocollection standards, the big one being Darwin Core, but they've recently expressed an interest in involving the geosciences a little bit more, and they've published a standard called EFG that's for geoscience museum collections. And this is the same diagram with what we're actually actively doing. Primarily, we've been working within the Smithsonian's own infrastructure, with the exception of registering our samples with IGSNs through CSAR, a little bit of linking to publications. I think this makes sense in terms of who's available for us to work with really easily, but it does limit our audience to people who already know about the Smithsonian. So if you don't know to come to the Smithsonian for samples, you're not going to find out very easily the way things are currently construed. I'm going to talk for a minute about the museum's work as a whole. So the work undertaken by the museum largely focuses on the biology collections. It's easy to see why. If you throw paleo in with the extant biology collections, that's 98% of your collections. It's 142 million objects. That's a lot of bang for your buck. And this is true across natural history collections all around the world. So the museum focuses in the things that I think people at this conference are very interested in, which is sharing its data widely and sustainably. And to that end, they've assigned persistent identifiers to all of our collection records. They've published biocollections data widely using Darwin Core, and they share the same biocollection data through portals like GBIF and iDigBio. The museum has placed a lot of emphasis on biodiversity and genomics, which are domains where a large old collection can be very useful. So take biodiversity, it's topical, it's pressing. You can get pretty far with large amounts of fairly basic specimen information. Aggregators like GBIF, pictured here, pool data from a large number of sources and then make it available through their website and API. And then they take pains to make sure the institutions receive credit for that data. So that's also very important to the museum. But I think the main thing is that biodiversity is about as good a use for museum collections data as you're ever going to find. The analogs on the geoscience side aren't necessarily there. There are aggregators like GeoCase, but it's hard to argue that there's the same demand for like really basic specimen data on the geoscience side. So what do I mean by basic specimen data? This is a just sort of typical sample specimen label. It's a sample picked out of the rock collection from the Yellowstone Park Survey, which is conducted by the USGS at the end of the 19th century. And it's very typical of what we have for historical data. You have sample identifiers that are basically useless outside of their original context. You have a rock or mineral name that was assigned in the field and probably has never been revisited. And then you have a collection string that, if you're lucky, you might be able to map within a couple of kilometers. You might have a unit name, you might have a collector, but you're going to be fairly limited in the amount of data that's available. And that's even assuming the catalog process goes perfectly smoothly, which often it doesn't. Cursive is a huge problem for us. And so the question I have when I look at this is like, is this amount of data enough for a current researcher? Like if you're looking for a sample to use, is this going to do it? I'm not sure. I think it depends, but I think a lot of times, and especially for rocks where precise context is really important, it's not going to do it. So one way that we can address this is to try to build citation histories from the literature. And that involves using so this is where the IGSN can be really useful. IGSN stands for the International Geosample Number. It's a persistent sample identifier resolvable at the IGSN.org domain. We obtained IGSNs for our collection in 2015, and through the System for Earth Sample Registration. I probably don't need to explain to you why persistent identifiers are useful, but in this case, the main benefits for us are that they unambiguously identify a sample, and they allow publications and databases to link directly to them. This helps with things like the overlapping catalog number ranges. There's also some bonus features to registering through CSAR, which is that our data gets put on the CSAR portal where we do get some traffic from. And it also would simplify adding new material to the collection, which is difficult at present just because the metadata isn't always compiled in a form that's easy to use, and we often have to do all of that work ourselves. I'm running a little bit low on time here, so what I basically want to end on is that we have taken our collection, we've gussied it up a bit so it's easier to find and use, and hopefully people will continue to use it a little bit more since with the IGSN going forward. I think the major drawback for a historical collection using the IGSN is actually just the scale of past literature, like the huge body of past literature, which is an issue that as an old collection we're really going to need to grapple with, and maybe start trying to use some of these tools like GeoDeepDive to build out these scientific histories, not just going forward, but also going backward. And that's where I'm going to stop. So if anybody has any questions, I'd be happy to take them.
Adam, thanks for the talk. You're showing us a picture of the specimen. Could you talk just a tiny bit about what you're doing to digitize the specimens themselves in any manner, like photographs, thin plates, whatever?
Yeah, I'd be happy to. So most of our digitation is just taking original specimen information, either from a ledger or a specimen label, or more recently compiled into a spreadsheet, adding that to the database. We don't tend to do a lot of photography of the rock collection because you don't need 100,000 images of basalt. We do a fair amount of photography of exhibit quality specimens, but that's never really been the emphasis of our digitization efforts. It's not the best use of our or limited staff time. What we are working on right now is geo-referencing the collection, so we can convert some of these locality strings to coordinates as best we can, which is really often not going to be much better than a few kilometers at best. But that's a lot better than just a locality string. We've done some work imaging like micro or thin sections for the meteorite slides. We have a big collection of Antarctic meteorites, but I've lost my thread. But mostly we've been working on enhancing the basic specimen data to make it a little bit more findable.
So I'm just interested in knowing, as obviously going back is much harder, but going forward, thinking about how do you look at the associations of various kinds of data, whether within or outside of domains that you can use to help connect and add knowledge to a collection. So things like biodiversity is not just about how many and where they are, it's about how the relationships happen among different things in a particular biome or ecosystem. And similarly for minerals, thinking about, okay, so is it the association of where that came from and its association with other minerals and that kind of thing. So think about ontologies and about making connections.
Like this is something that people are aware of and are working on and are trying to set up these relationships like these predator-prey things. That's pretty far removed from what we do. And there's a limited number of ontologies that are available that I'm aware of for the geosciences side. But the big issue is we just haven't gotten there yet. Like we're just not there yet. I saw Kai's talk yesterday, and he's defining these terms pretty granularly, and we have fairly basic simple lithology stuff that we can use, but like mapping out these relationships would really rely on like a much better understanding of exactly where these specimens are coming from, like geologic units, for example. You can know a location, but not the unit, and like you can have a lot of units in a very small space. And that makes those relationships tricky to tease out if you're working from very basic catalog information. And so like really the strengths of the museum collection going forward, at least on our side, like it's going to be the stuff that is less dependent on those relationships, stuff like xenoliths or meteorites, where the specific spatial component for the older collection just isn't as important. So I know it's not the most satisfying answer, but it's tough with the just the quality of data that we have for the first 300,000 specimens in the collection.
The question actually following on from that. So it's really nice to see Tadwig mentioned there too, and it's closer than you think, I think, because some of the ontologies that ESIP interoperates with in Obo Foundry, that's in the life sciences, and they're also being used by Tadwig. So we have a link. And with iDig Bio some years ago, we just text mined iDig Bio's habitat descriptions from the notes for all their plant collections from like 1770 something. And it was just a little experiment, a 2-week thing that we did. And you can retrieve a lot and just get those IRIs on your samples. So to make an initial link, I think we're quite a lot closer. Do you have this? I assume you have this in a database with text fields that we can text mine and add up. Because if we make that link, it's also going to then link over to suite ontologies that are used in this community. So I think we're closer than you think.
Yeah, so all the data is in a database, and it's available through various aggregators. I think the biology side is a lot further along. The geology side, and this is like getting completely away from biology to completely abiotic samples, is where you run into, there are resources like this exist, but not to the level of granularity that I was seeing yesterday. And so the other question that I always have when I think about ontologies is, are we sort of implying a specificity of the data that we can't actually support? So if you say, if a rock has been given a field name, and then you map it to a really specific ontology that's based on a chemical composition, is that sort of overselling the quality of your data? And that's something that I don't know how to address for a historical collection, because it's easy to imagine mapping a vocabulary to like an ontology, but is that meaningful in the way that the ontology is going to make it look?
Yeah. So very quickly, we just do that on the automatic basis to get like 50% of the way there, and that helps the manual annotation later. So it's a step.
Thank you. If anyone's interested in talking about physical specimens, I'm around.
Excellent. Well, as I prepared to introduce our next introducer, I also wanted to mention, and perhaps this is also a part of our incentive program to clear the room after the session is over. Esri has generously donated a limited number of Don Wright's new book, GIS for Science, as a gift for attendees at the meeting. But it is a limited number, and Don's going to be out near the reception desk signing copies of the book during the break after this session. So I encourage you to go talk to Don, pick up a copy of the book. First come, first served. So make sure you get there early, and have a chance to take that book home. I'd like to now introduce Megan Carter, our community director for ESIP, who I'm sure many of you have had a chance to get to know, as she is the master of all of our community activity support work. And without her Herculean efforts, we would not be the smooth running collaborative organization that we are. So I'll pass the torch to Megan so she can introduce our next speaker.
So like Carl said, I have the tremendous honor today of introducing Dr. Don Wright. Before I do that, I'm just going to change the slides. I don't trust that I can do two things at one time, so give me 1 second. Right. So Dr. Don Wright is Chief Scientist of the Environmental Systems Research Institute, aka ESRI, a world-leading geographic information system software and data science company. Core to ESRI's mission is to inspire and enable people to positively impact their future by connecting them with the geoanalytic knowledge needed to make the critical decisions shaping the planet. As Chief Scientist, Don is responsible for strengthening the scientific foundation for ESRI software and services, while representing ESRI to the scientific community. As such, she has served on many advisory boards, including the NOAA and EPA Science Advisory Boards, the National Academy of Sciences Ocean Studies Board, and the Science Advisory Boards of Conservation International, Compass Science Communication Inc., University of Minnesota's Institute on the Environment, and the Ocean Discovery X Prize. Don is also a member of the EarthCube Liaison Team within EarthCube Governance. She is a fellow of the American Association for the Advancement of Science, the Geological Society of America, the California Academy of Sciences, and Stanford's Leopold Leadership Program, as well as former Oregon Professor of the Year. She enjoys road cycling, 18th Century Pirates, her dog Riley, and SpongeBob SquarePants. Follow her on Twitter at DeepSeaDawn. Carl stole my thunder, but Don has edited a book that is hot off the presses, and I'd like to reiterate that it is very lovely. I took a look at it myself. We have 150 of them available, and she will be there to sign this morning during the break. Also, very excitedly, Don has created a Lego creation to go with the talk this morning, and a salute to the 50th anniversary of Apollo 11, so check that out tonight at the Research Showcase. Don, we're so excited to have you here today.
Thank you very much, Megan. And to all of my ESIP friends here, I'm so delighted to finally be here at an ESIP meeting, to see so many of my friends and colleagues in the audience. And this community is so wonderful. It's so effective. It's so productive that in thinking about what I was going to say this morning, I thought, well, there's nothing really new that I can say to this outstanding community. So one of the things I did want to emphasize was the spirit of giving in this community, and how you realize that the more that you give to each other and to the science community, the more that you receive. So to this end, I wanted to actually frame these remarks as a tribute to you. And I think my remarks will be very nicely following on from Adam's presentation, except I'll be focusing on more modern digital collections. And you see the Star Wars theme here. It looks rather daunting, so let me explain why I've why I've done this. So this talk follows on from one of the 8 principles of digital resilience that I've been talking about over the years, and a couple of references to this idea of a digital resilience is on the bottom of the screen here. The idea that there is climate resilience, community resilience, even personal resilience. But if we want to live in a more resilient world, we need to have resilient data. So there is digital resilience as well, and it ties into the theme of the use, increasing the use and value of information that you are focusing on this week. Now, in order to explain more about this, I want to channel Master Yoda for just a second. So bear with me. Master Yoda made a very important insight in The Phantom Menace. He said, "Fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering." Now, as a data Jedi, I want to turn this around and say that ease leads to exposure. Exposure leads to adoption. And the idea of this, which is what Adam touched on as well for physical specimens, is that if we make it easier for our colleagues who are specialists and non-specialists alike to access and to understand the data, the information that we work so very hard for them to have, that ease will lead to them being more aware of it, spreading the word about it, and hopefully for more people to actually adopt what it is that we have built. Because in the end, we want people to use what it is that we have built and that we have put our blood, sweat, and tears into providing for the community. So this is the framing for my remarks. And one of the first ways that we can make things easier is to provide our data in terms of viewers. So a viewer is something that allows, especially non-specialist users and audiences, to understand what it is that we have. So in the case here, we have at Esri, we have a viewer to the 80,000 Landsat 8 scenes that we have in our system in collaboration with Amazon Web Services. And in this viewer, we go through all of the different bands of these Landsat scenes. It makes it easier for the user to understand what those bands are, what they look like, what the profiles are of these data in terms of the temporal and the spectral signature, and really to get a better idea of how it is that Landsat data can be useful, can be used in a number of different applications, even if you are not a remote sensing specialist. And the idea here also is to use services. So these are not just pretty pictures. They are not cached images. They are actually services that connect to the actual living data. So it's full information content. At Esri, we spend a lot of time downloading these scenes every night, provisioning them in the viewer so that the user has access to these image services that are dynamically processing and mosaicing everything on the fly. So a viewer is one special way of making things easier to expose and to adopt. You can go one step further to an explorer. An explorer has all of the capabilities of a viewer, and here you're looking at an explorer which allows you to compare between the Landsat imagery and the higher resolution, more detailed Sentinel-2 imagery. And in this case of the Explorer, you can swipe between the two so that you can see the differences. You can also do very simple analysis like change detection or masking, and you can compare, in this case, the NDVI color ramp of Sentinel-2 with what's available for Landsat. And so an Explorer is one step further to help your audiences. And I want to point also to the paper by my colleague Steve Cope and others, which talks about this in much more detail, particularly from the standpoint of Earth observation data cubes. So please take a look at this new paper that just came out in a special issue on observation data cubes in, appropriately, the journal Data and appropriately the open access journal Data. So viewers and explorers are very helpful. Also, if you are able to provide a template so that your users can build upon the foundation that you've laid for them, the idea of templates in all varying forms. What you see on the left is a blog post about a web app template because we're doing so many things on the web. So if you create that framework for your users to then hit the ground running with their own work, that's also very, very helpful. And in the case of this particular blog post, the idea was imagery templates, particularly for the detection of burn scars after forest fires, so that it's possible to understand the forest succession and the vegetation, the forest regeneration and the vegetation succession after a forest fire. If you have the template coupled with a tutorial, many of us have spent many, many years writing tutorials or cookbooks for our applications, and that continues to be one of the most powerful ways that you can jumpstart your users so that they will use and adopt. Now at Esri, we have an initiative called Learn ArcGIS, which has a whole series of helpful modules, tutorials. Many of these have been written by Esri staff, but we're finding more and more now that these lessons are being written by our colleagues in the community. So this is an example of a Learn lesson that was written by our colleagues at NOAA. So please take a look at those resources because they're growing all the time. Another really powerful way to help users to understand, use, and adopt is through dashboards. Dashboards are becoming more and more popular. They are a wonderful way to give insight into your data at a single glance or a single screenshot. They provide a variety of visualization elements that you can see here. And of course, dashboards are powerful because the idea of a dashboard is to give you access to real-time or near real-time streams from instruments, monitoring stations, activities, and so forth. So this is one example from the International Association of Fire Chiefs. This is an example from the USDA Forest Service as part of their forestry inventory analysis. So you can see the variety of visualization elements that they are using, all coupled, of course, with an interactive map. The city of Tempe, Arizona, now has an EMS dashboard to track opioid abuse and to deploy first response services accordingly. And this one is one of my favorite. It's the Puerto Rico Science Trust. They have created this dashboard to monitor the activities on that island in terms of the provision of clean water as that island continues to recover from Hurricane Maria. So you can see a variety, no two dashboards need look alike. There's a variety of visualization elements and provisions to the data streams that you can provide in these. At Esri, we built a couple of these ourselves. This one was built in collaboration with NOAA's Coral Reef Watch to look and to track what's going on with coral reefs at risk of bleaching. This is another interesting one because it tracks the nearly 4,000 Argo floats that are out in all of the world's oceans. And this particular dashboard was built in collaboration with JCOM Ops of the Argo program, with the WMO and with others, to show especially the floats that have been active in receiving data over the last 30 days. So these are very, very important for real data, in near real time, but it's also possible to build a dashboard from imaginary data. So this is one of my favorites. It's a Batman villain dashboard. The data are imaginary, or depending on where you live and what politicians are in your area, this may be real data. At any rate, you can build dashboards in all different types and variations. Now, another very important way to increase use and adoption is for two communities or two platforms to come together and decide to integrate, to work together, to interoperate. So to this end, I just have a couple of slides that shows a little project that's ongoing now with the EarthCube liaison team in collaboration with the EarthCube Science Support Office under the leadership of Eric Lingerfeld, along with our Esri Living Atlas team. So if you've not heard of the Living Atlas, it's something that we've been working on at Esri for a very long time. It's one of the world's largest GIS digital libraries. It takes it looks at all of the resources that are in ArcGIS Online, and you can see on the right that we've got considerable activity there. It's a big community, 11 million public items, 2,200 terabytes of data, over 160 million map requests made by 1.6 million users every day, 4.5 billion map tile requests every month. So it's a huge global community. The Living Atlas of the world takes the top 1% of that, the most authoritative, the most curated. And so it's a very, very valuable resource that we are going to continue to build. It is permanent. It is not subject to the vagaries of NSF or other funding. It's not going to go away in 5 years. And so the idea is to couple that in some way to connect that community with our EarthCube community, particularly through geocodes, which no doubt everyone in this audience has hopefully heard about. Hopefully you attended Eric's recent webinar about geocodes in terms of this geoscience cyber infrastructure for open discovery in the earth sciences. It's a wonderful emerging platform that will bring together the various tools, the REST APIs, the Python R and MATLAB notebooks. And so the idea was to integrate between these two communities and of course to make this easy. So one way that we've started, this is in its very formative early stages, at Esri over the course of one weekend, we built this interface. Now, one weekend, of course, we are software developers, so it went a little faster for us, but it was fairly easy for us to build this interface from the Living Atlas of the world to geocodes and to receive or to capture real-time data streams, particularly in terms of the CORDS data, the cloud-hosted real-time data services that are in geocodes, real-time weather data from weather stations. We plunked those on a map so that you could see the locations and get the spatial context of that data stream. This was using vocabularies from geocodes, using mainly the JSON LD API. And so we were able to capture that, put it into this interface, and then at Esri, we can run simple analytics against those data, particularly within our hosted Jupyter Python notebooks. So this is something that we are very happy to be working on. And again, another example of how to make things easy so that they can be later adoptable. So do we just wave a magic wand or use the force, hopefully not the dark side of the force, in order to make these wonderful apps and dashboards and templates and tutorials? Of course, it's not that easy. In fact, to make something easy is not easy. It takes substantive or substantive scientific rigor. It takes very serious engineering design, design that is likely to fail and to fail early and often. So for those of you who are in the fail workshop yesterday, I think that's a very important workshop, a very important activity, because this is all iterative. Now, there are many design principles that can come into play to help us as we try to use the good side of the force to make all of these wonderful resources. I do not have the time to go into all of those design principles, but I just want to mention very quickly that this is something that needs our continued attention. Many of us face this scenario here. These are two developers. One says when a user takes a photo, the app should check whether they're in a national park. Fair enough. Sure, that's easy. It's an easy GIS lookup. Give me a few hours and I'll have that done. But we need to check whether the photo is of a bird. Oh, okay, that's different. I'll need a research team and 5 years to do that. So the moral of this particular little cartoon story is that, especially in computer science, it can be very hard to explain the difference or the experience between the easy and the virtually impossible. Now, one of the things that we're trying, and many of us in the audience are using this already, and at Esri, our R&D and our creative labs are using this principle as well, that of responsive design, where what you are building, the design and the software development, needs to respond to the user's behavior, to the user's environment, and I would say to the user's data stream, based on what they're experiencing, based on where they're at. So if you are using responsive design, it makes it a little easier to build and to maintain complex systems, regardless of whether they are fronted by a complex app or a simple app. And in designing these systems, it's very interesting that for many of us, the old principles of data modeling that we used to create some of the data models in the 1980s and 1990s and the early 2000s using the conceptual, the logical, and the functional design phases, that still holds today. Those are still foundational activities. But one of the challenges is to attach visual design to that conceptual development. And this is just a whiteboard that shows how some of our developers and designers have been wrestling with that, particularly when it comes back to tying into the real world. Now, I don't need to talk to this audience about FAIR. We are all Jedi Knights when it comes to findable, accessible, interoperable, and reusable data. This is a wonderful circumstance. I want to take just a second to acknowledge again Shelley Stahl and our own Aaron Robinson and many of us in the audience who are part of this nature commentary. Very important to get this out in nature about FAIR data and about the consensus statement, the projects going on there. So if you haven't already seen this article, please download and read it. And it's very nice to see now how there are variations on FAIR that are coming to the fore now, including this variation to make data fairer in terms of ethical and revisable. And there's a nice article about that at the bottom of the slide. And also Bob Downs and others are proposing an AGU session about the uncertainty associated with FAIR data and also trust as well. So fairer is going to become a theme. This is a slide that I'd like to thank Mark Parsons for, because Mark introduced me to this community which focuses on the ethics and the practice of care in maintaining information. So this is a very important new collaborative. Check out this white paper with 40 plus contributors. It's a fascinating and very rich read, and also with an eye toward making things easier to adopt. We need to get the word out about reproducibility. This is a big issue in science in terms of being able to reproduce a result based on the same data and methods, but also replicability in terms of being able to produce the same result with different data and different software. So this is a big issue. There is a nice workshop that talks about this. And so please take a look at this Arizona State University workshop, which also talks about tools to make this easier to adopt and to implement. So in ending, of course, I have to end with may the force be with you. A huge salute to all of you who are working along these lines. Here's to making things easier so that people will be more exposed to it and so that they may adopt it and make use of the data and the best practices that we have been advocating. You can get a hold of me at the information here. These slides are on Figshare, but I've taken the additional step of putting a lot of information into notes. So you can use this URL to download the notes. There's a lot more information, especially with regard to the Esri resources. So I've not yet had my breakfast. So Master Yoda says it's time for breakfast and maybe for questions. Thank you so much.
I was wondering about I really appreciate the focus on being able to provide ease of access and accessible interfaces. Maybe could you talk a little bit about the challenge that many of us face in terms of actually trying to first identify and align our ease of access and applications for the particular target user communities that we're working with, and maybe the insights that you've been able to gain from being able to look at who ends up using applications who may even be different from the users who they were initially designed for.
Yes, that's an excellent question. And oftentimes, I have been surprised so many times over the course of my career by something that I've built and put out there for one community, and another community has taken it up and is running with it, and actually running with it in ways that were unintended. You know, this is the whole discussion with the early days of metadata to make sure that the intended audience is using your data. I think what is helpful now is to have, we hear about this with politicians, with media focus groups, to take some time along the evolution of the project to actually not only think about who we want to be the audience for these data or these resources, but to actually bring them in at certain stages of the development so that we're not just building something, putting it out there, and then hoping for the best in terms of not only the intended audience, but the unintended audience. So that's part of the conceptual, the logical design phases where you're actually bringing users or bringing non-specialists into the discussion at those formative stages. I think that's helpful.
Any other questions?
Okay, well, the force is with this audience, so no worries. Thank you very much.
And I'd like to mention that actually a number of the projects and activities that Dawn highlighted in her presentation also have posters outside here, so that there will be an opportunity for you to dig a little bit more deeply and engage with some of those projects after when we have our poster session. I'd like to now introduce our next introducer, Catherine Kramer, who is from one of our meeting sponsors. So we have a double appreciation for both stepping forward to help with the introductions. But AUI is one of our sponsors, and Catherine is going to introduce our next plenary speaker.
Thank you, Carl. I am really thrilled to be here, and thanks for the introduction for the introducer. That's particularly special. I'm Catherine Kramer. No, seriously, somebody needs to introduce you. And I'm from Associated Universities, Inc., AUI, and just in the shameless promotion department, we do have a poster outside. I'm looking forward to talking to many of you later today. And I am particularly thrilled to be introducing Judy Tweet, and her last name is pronounced Tweet, which of course is wonderfully appropriate for the topic she's going to be talking about. And Erin, I know, thought I might enjoy introducing Judy because of the connection, as Carl mentioned, that AUI has to data education and work that I've been involved with for a long time in data literacy. What Erin didn't know is that I'm also a musician, and she told me there are lots of musicians here in the ESIP audience, which I think is really cool. Many of us have noticed there's a real connection between science and music, and the work that Judy is doing is in this realm. Judy grew up here in Tacoma, which I love Tacoma. It's what a fabulous place. My first time here. She's a fifth generation Washingtonian, which is really amazing. She studied philosophy and human rights in college and went off to work for the ACLU. And I'm mentioning that part of her history because that really, I think, plays into one of the driving forces behind the work that she's doing now, which is how to help bring everybody into the conversation so that everyone can be involved in these really important discussions about climate and climate change and climate science, and doing that through a really unique, interesting, and musical approach to how climate data might be expressed through music. And I'm really looking forward to her talk. And also, I'm hoping there'll be time for a little more discussion later. Probably not a jam session, but I'm really looking forward to hearing more about her work. And Judy Tweet.
Thank you for that introduction. I was really excited when I was invited to speak here for two reasons. One is because, yes, Tacoma is my hometown, and so welcome here. And also because the theme of this conference is so near and dear to my own research heart. I started graduate school in 13, doctoral program in atmospheric sciences at the University of Washington. And I should say, yes, I did come from a background in philosophy, and then I kind of meandered back into the sciences, partly for the love of this place. I'm really in love with the lands of the Pacific Northwest. And I was also fascinated with physics of fluid dynamics. And so that the atmospheric sciences and climate research was a way to kind of combine those two interests. But 2013 was a weird time to start graduate school. Well, actually, I should say it was an exciting time to start graduate school because the IPCC Fifth Assessment Report had just come out. As I was working on my master's, we were gearing up for the Paris Accords. And then after I completed my master's, nationally, we did this about face and pulled out. And so that all of this era that I was working in as an early graduate student contributed to making this decision to switch from doing basic climate research. I was doing modeling, looking at atmospheric teleconnections, to focusing on how we build more public trust in climate science and how we make it more accessible. And a lot of my learning about that was both from diving into the research on science communication and also paying really close attention to how we were teaching climate change. So I had opportunities early in graduate school to TA our large lecture courses on global warming, which are designed for their survey courses for undergraduate students, many of whom are not majors, and just get the opportunity to do a 10-week deep dive into the science of climate change. And so we often, when we're teaching that class, we show lots of data. And this is an example of really good data visualization here from Climate Central, showing the data set of carbon dioxide from ice cores from La Dome over the last 800,000 years. And again, I said this is a great climate visual, and I like the products from Climate Central. The colors pop, the language is clear, there's no jargon, the text is large enough that you can read it. So we've made a lot of advances in good visualization, and yet what happens to the students, the audiences, when we show chart after chart? Specifically when the information is distressing. Well, I asked that question through surveys of the undergraduate students that I was teaching, and I've done this for a couple of years now, so I have a few hundred responses. And these are the most common responses that people say. The survey question is specifically, how do you feel when you read, write, or think, or learn about climate data? And the responses are, this is bad. I feel powerless. I don't know what to do. We're doomed. This is scary. I'm panicking. And it's hopeless. So panic might be a useful response if you need an adrenaline rush to run away from a lion, but it's not a useful response when we're trying to build up a large, robust public discourse, scientifically informed public discourse to make democratic, science-driven policy decisions. So how do we help people who are responding, students in particular, public audiences, when they're confronted with this information and their response is all too often, this is too much. I need to think about something else. Because the next step after that, their mind goes to that is, I gotta move on, right? Lunchtime, great. I can compartmentalize what I just learned and put it in a box so I can go on with my life. And that's actually a very reasonable response to all those emotional feelings if those are coming up for people. But this is a problem if we want people to be able to, to process what they're learning and to stick with it. So in this talk, I want to offer 2 suggestions for aiding data-informed action. And this is the first one, motivated by this phenomenon that happens and people just want to shut down when they get the information. So we need ways to emotionally process environmental information, and that's particularly important when it is distressing information. And that's where my music comes in. So I'm going to give you an example. I'll walk you through how I often present data as music. And that starts with going to the data set that I'm using. Arctic sea ice. It's important when I'm introducing this to people that they know what it is, where it comes from, what it looks like. So I will often say, this is a valuable service to everybody around the world because it is highly reflective, and so it helps to keep the Earth's radiation budget in check. But it's also incredibly important to the people who live in the Arctic, who depend on the ice as an integral part of the ecosystem for their subsistence living. And then show the data, right? So the satellites have been monitoring the area of the Arctic Ocean covered by sea ice for the last 36 years. And so this is a visualization of that satellite record that's been slightly doctored up by a designer so that it it's got the blue to red color gradient, large font, very easy to see. But it's hard to kind of move past, okay, but so what, or how do I process the fact that there's been a decline in the area of sea ice over the last 36 years, a couple million kilometers. So a way to represent this musically is to take those notes and to map them, instead of mapping them to the line graph, map them to a keyboard. That's what I did in this case. So this is a piece for piano. And there's 2 things going on. I was like, okay, I want to treat the keyboard like a number line for this piece. And I'll have the left hand, I want to be able to kind of situate people to where that 0 line is on the keyboard. So the left hand is going to play 4 chords that repeat over and over again, and those are keeping the rhythm of the seasons. And those will hover right around the area in the keyboard that's representing the 0 line. Right hand is going to play 1 note for each month of data. So when the right hand is above the left hand, you know that that month of data was higher than average, the area of sea ice, and if it crosses over, it's lower than average. So this is both a sonification of this data set, but it's also a visualization through that gesture of the performance itself. And this is the score, freely downloadable for anybody who wants to learn it and play it. But I want to actually let you hear it too. So this is a recording made last fall by a Bellevue-based pianist, Christina Lee. And it's just under 3 minutes long. now you've heard the sea ice data and listened to it. Just curious what, how this feels different for you, perceiving it visually versus acoustically. We can maybe talk about this later, but I'll share a few of the things that I've learned along the way and are also kind of part of the motivation for doing this. When we express data as music, we represent a time series data set over time. And that's a fundamental difference between a visualization and a sonification. Almost all climate data, many of the earth science data sets are time series data sets. They're showing change over time, and yet the visualizations themselves are static. So when we turn it into a sonification, it preserves that element of change over time. It can help kind of create that portal to understanding and sort of being open to the timescales that we need to think about associated with the data sets. The second, as I talked about earlier, right, music conveys emotion. It's an incredible conduit for conveying emotion. It doesn't have to. You can do a sonification that is emotionless, but it is very helpful for bringing expression. And in this case also, as with a live performance, you can bring gesture into the way that you're expressing the data. And here also, so this piece was both visual and sonic. When we're listening to data, we can relax our visual cortex a little bit and activate the auditory cortex. So when we're thinking about how our brains are processing, relating to, remembering data, adding in more ways to activate the different regions of the brain can help with new ways of processing and relating to the information. It's also a shared visceral experience. So it's quite easy when we're presenting data visually to choose to look away and to check something else, right? When we're playing data over the speakers and it's being presented as vibrations in the air, that's a shared experience that everybody is kind of participating in at the same time. And so sometimes there's some interesting conversations in classes too when people are talking about what they've heard, and it does allow for this kind of sense that we've done this together. And then finally, I think of this as making music from data as a way of memorializing the stories that the data tell and showing the audiences or the users that I think this data set is so important that we ought to be bringing art into the way that we express it. So it should be chosen carefully, but these are many of the things that have come up as really salient features of data sonification. Okay, so I said I was going to offer two suggestions for aiding data-informed action, and the first one is this helping audiences process and emotionally process data. The second one I want to get to by asking you all a question. And so if you have a pen and paper or a little notepad on your iPad or whatever, you can just take a quick couple notes. My question for you is a question that I ask students in classes too on this same survey. And I ask them this after they've had some, a unit on cryosphere, Arctic climate change. The question is, what are your associations to Arctic sea ice loss? First thing that come to your mind. A couple words, a phrase, an idea. 20 seconds to think about that. Okay, so now we're going to do a really simple unscientific survey by raising your hands. The categories that I will often bin the student responses into, and this is actually already a distillation of that, are up here. So how many of you said a word that words that relate to polar bears, animals, or ecosystems? And I recommend looking around too so you can kind of see, okay, so maybe half. How about words, ideas, thoughts about the cryosphere? Sea ice, glaciers, ice sheets, snow, a little less. How about climate change and sea level rise? Okay, maybe about a third. And how about Arctic communities and human impacts? Okay, about a third. So what I've found from the undergraduate student responses is polar bears is the most frequent association. followed by animals in ecosystems. Arctic communities and human impacts comes up in less than 1% of the student responses. So there's a total absence of connecting the human impacts with ice loss, warming in the Arctic, and the region in general. So my second offering is that when we're trying to use data to inform action, we make sure that people know about the human connections to that data, whether or not that's the impacts or the people involved in them. And I want to share now an example of a project in process. So actually, I'm just giving you a teaser for how I'm doing this through my work by expanding the collection of data sets I'm making, sonifications about Arctic data. And so the project that I'm working on this summer is weaving together what I do, which is sonifying data, with stories from Native Alaskans who have lived for many generations in the Arctic and are experiencing climate change firsthand. And so we've met together and they have recorded stories of relationships to their land and how they're seeing it change before their eyes, what that means to them. And then I'm taking data sets that relate to the stories they tell, and we're going to weave those together into soundtracks. So we'll be kind of like what you listened to before. There'll be digital soundtracks that also have this very clear human element connected to it. Esau is one of my collaborators, Esau Sinuk. He is a Native Alaskan from Shishmaref. I checked in with him last night. I asked, can I share a couple of the clips from the recording that you've made that are going to go into our soundtracks? And he said he'd be honored to share them with you. So I will do that now. Yes, I did say he's from Shishmaref. This is one of the small native villages in Alaska that has voted to relocate due to coastal erosion. So this is how he introduces himself.
My name is Esau Sinuk. My family name is Kagakuila. Parents are Warren and Bessie Sinuk. I am from Shishmaref, Alaska, and I am.
And then throughout his recording, he talks about growing up in Shishmaref and how it's changing now. And then he talks kind of about climate change and how he wants other people to think of it. And this is an excerpt from that part of the interview.
It's more than just actual people having food, homes, their loved ones have been. It's people that actually have to move because of climate change. More people would understand that. Pay attention to polar bears, which is good because our polar bears are being impacted by climate change, but have people living in the Arctic that are United States citizens that have to move their home because of climate change. I would love more people to understand that than just sea ice and polar bears. It's actual people, indigenous people that are living in the Arctic.
So we'll be releasing these soundtracks this fall under arcticstories.org. They're not that website's not active yet. We'll have it up September, early October. So be on the lookout for that. Also wanted to mention Esau is an undergraduate at the University of Alaska, although it's unclear whether he'll be able to finish his studies after the significant budget cuts and the uncertainty of whether the university will maintain its accreditation. So I wanted to cast this off by sharing also one other source of inspiration, and particularly an inspiration for connecting the human aspect of what we do with our science. How many of you know Robin Wall-Kimmerer? Yes, okay, I'm really excited that I get to introduce many of you to Robin Wall-Kimmerer. She's a professor of ecology at SUNY Stony Brook. She's also a member of the Citizen Potawatomi Nation. And I have been reading her book, braiding sweetgrass here. It's incredible. It's just opening up so many ways of thinking about the work that we do and the data that we do and the value of Indigenous knowledge and what that can bring to sort of open up how we're thinking of environmental sciences. And I'll share one short excerpt from her, for you, in a section she wrote about this place, the Pacific Northwest, and how the Coast Salish people had ceremonies to call the salmon and to live in harmony with them. She talks later about the work that the scientists and ecologists are doing for similar reasons to live in better harmony with salmon. And she says, I've never met an ecologist, or we could just swap in earth scientist here, who came to the field for the love of data or the wonder of a p-value. These are just ways of having crossing the species boundary, of slipping off our human skin and wearing fins or feathers or foliage, trying to know others as fully as we can. Science can be a way of forming intimacy and respect with other species and lands that is rivaled only by the observations of traditional knowledge holders. It can be a path to kinship. So I highly encourage you to check out her work as well. Oops. And I want to end now with one final example of a very serious and very professional way of representing data in new spaces. Since you can't see my hands very closely, I've posted on here. What's on my fingernails right now? The latest peak in carbon dioxide emissions peaked at 415 parts per million this year. So I had the delight of asking a friend of mine, a scientist who does this in her hobby, to paint that on my nails. And it has sparked conversations about climate data in spaces that I never would have expected. So this can also be fun and creative and lighthearted work too. Thank you.
Thank you so much for a really interesting talk, and having this talk follow Dawn's talk really has stirred some interesting thoughts in me. Some of the stuff that Dawn and other people at ESRI and other places are doing is using maps to tell stories, and I think you mentioned that there's a lot of time series data. There's also a lot of image data, and it seems to me that, or I guess my question, I actually have two questions, but have you explored the possibility of using images and drums together to do something interesting? I'm not sure what it would be, but it seems to me that taking the time, the temporal, the 1D temporal resolution or whatever representation, and then moving it into time. And she showed, one of the things that Dawn showed is the sort of the slider thing. And for comparing easily two times or two images, it seems to me that integrating audio into some of those stories and those two-dimensional techniques would be really interesting. The other little tiny question is, it's not really that tiny, unfortunately, but have you thought at all about how you integrate uncertainty into the music? It seems to me that we think about, it's funny because we describe uncertainty as noise. So it would be interesting to hear it sometime, maybe.
So the short answer to both those questions is yes. To the first one, I have not yet found a way that I'm satisfied with for sonifying spatial data. So I've steered away from that, and I focus just on time series data. However, people are sonifying spatial data, and you can sort of see like a cursor run across a map, make sounds. As for drumming, yes, that's something we're exploring, my collaborators and I, bringing in one of the collaborators, Haley Hannah Stepton, is a dancer and a musician, Indigenous musician. And so weaving together some drumming. And there's lots of ways you can map, right? So I showed you mapping data to pitch. You can map data to rhythm. You can map data to the timbre of a sound. So rhythm is another way, sort of changing the pace of something. Definitely an option. Second question about uncertainty. Yes and no. Yeah, so you can have a sound become more and less focused. And there's plenty of techniques to do that. I did not do that with the piano keyboard piece. I have done. So one thing that's tricky is like if you have too much information in the sonification, it's really hard to kind of figure out what's going on. So I have chosen data sets where, you know, there is a very clear story of what's going on. We know, you know, what's causing it. I don't choose to show data sets where I think there's a high level of uncertainty. So the story behind Arctic sea ice is that it's melting, and people need to know that and connect to it. So yes, you can represent uncertainty, and I think there's a lot of curatorial choices in how much you want to represent. I've done some pieces where I had multiple sounds at once representing different model simulations. It's interesting, but it kind of also just gets noisy, and it's hard for the ear to figure out what's going on. Yeah.
In the beginning, you said that sort of the motivation for this sonification comes from the students who were giving you this feedback of feeling hopeless and sort of powerless. And I'm wondering if you have noticed any results from this sonification that has led you to feel like this has impacted that or prevented that sort of compartmentalization that happens. Because I feel like for me personally, the increased intensity of the sonification and the music makes me feel even worse about it than I did before. So I wonder if you've noticed any effects like that, or if there's any positive gains that you've seen.
Yeah, thank you for that question. And the answer is, you know, yes and no qualitatively. And you're not alone. You know, I have had people tell me like that really overwhelmed me. It made me feel so sad. I also follow Katherine Hayhoe quite closely. You know, a really rock star data climate scientist and driving a lot of changes in climate communication. And she and others are saying like, look, if we can't talk about this problem, if it's not in our conversations, then we can't get to solutions. And what I have found is that people want to share the soundtracks. They're like, this is interesting. Let me, you know, share it on social media or bring it up with my family. Just last week, I heard that a pianist performed this piece in New York as a memorial service, at a memorial for a scientist who passed away. So it can get into spaces where, you know, you wouldn't bring a data set into a memorial service, right?
Yeah.
But you might say, like, this person dedicated his life to science, and we're going to play this here honoring that. So it just opens up more spaces. I have also had some students say, actually some audience members, this is from a public talk, one woman came up and said, I almost didn't come to this because I find this information too alarming, and I think maybe that was sort of getting into kind of too many impacts. But she said that this one actually helped me. So it really depends on the person. There's no one size fits all.
Awesome. Thank you so much.
Okay, great. Judy, it's good to put a face to a name.
Yeah.
Patrick from the Clean Network we talked to.
Yeah.
But so kind of a follow-up to Connor's question is that what you've presented so far today, I think, focused on awareness. And I'm wondering if you've done any work to look at possibility of using sonification to create empowerment and action after the awareness is developed, such as using sonification techniques to look at the impact of choices and decisions moving forward and the possibilities of or act creating new sonifications.
Yeah, so I don't talk about my political activities and my advocacy here. I wanted to show the sonification, and I think some of those sort of just go into different domains. I put on a different hat, and I go and talk with unions about climate and clean energy and the work that I do, for example, and how we can advocate together. But particularly in educational settings, I didn't have time to show this, but I've done workshops where I actually put data into students' hands and ask them to sonify. And most recently was a workshop with middle schoolers. And it was so interesting to see. I didn't show them a visualization. I gave them weather data, and they could choose from cities around the world. And, you know, some of the cities don't have a clear climate signal, and others do. And through this process, first of all, they were like, whoa, what is this? Are we doing math? Are we doing music? Like, I don't know what subject this is. But then secondly, like as they were working together and they had different data sets, they were talking and they realized, I don't see climate change in this city, but I definitely see warming in Sydney, and I see warming in Fairbanks. And so they realized like this was sort of understanding through the process of sonifying variability, natural variability, that it's not the same everywhere. So that was a really interesting process, and I'm happy to share more about that if people have questions afterwards. Thank you.
So that was quite an exciting way to see how we can think creatively about creating the impact from the data that we often find ourselves focusing on, and reminding us again about that's ultimately where we want to end up, is creating impact and action from the data and results that we're creating. And with that, I'd like to introduce our final introducer, Jocelyn Elia, who is the lead for our very active ocean data cluster, for our final plenary speaker for the morning. She? Uh-oh. Aaron, I'll ask you, as you may have it handier. There was a head count.
Morning, everybody. So it's my pleasure to introduce Jennifer Hennessy, and I think it's a great way to close this plenary this morning. Jennifer comes from Governor Inslee's office and is an ocean policy expert. She has connections to Don Wright, and it was really an interesting, I think, an organic way that we have sort of flown through this morning. So with that, I'd invite Jennifer to the stage.
Well, good morning, everyone. On behalf of Governor Inslee, welcome to Washington State, for those of you from out of state. And on behalf of myself, thank you for coming to Tacoma, because it is my hometown, adopted. I'm originally from Olympia. So for those of you that don't make the trip down to Olympia, this is our Capitol building. And it's a beautiful place to live. And as was mentioned, I hail from the Northwest. I did go to Oregon State University and had the privilege of taking classes from Don many, many years ago, so far too long ago. And in starting this morning, I wanted to share a story. A good friend of mine went to our 10-year high school reunion a while back. I had to miss it, so I wanted to hear from her how it had gone. And what I most remember from her report back was this anecdote. You see, every time she would catch up with someone, inevitably the conversation would turn to, so what do you do? And she would respond, well, I'm a microbiologist. And the response inevitably was something along these lines. Ugh, science, I don't get any of that stuff. And they would turn away and go talk to somebody else. Usually my friend would report that this was inevitably somebody who was a teacher or a computer scientist, a software engineer, something along those lines. And her explanation really was that they didn't have anything in common. They didn't care about science. So that's kind of depressing for this audience, I'm sure. But I really think she missed an opportunity to connect with them and make her work not just interesting, but relevant to them. You see, my friend, she's doing really important work. She works in a lab that is developing diagnostic tests, treatments, and even cures for cancer. So what if instead she had opened this way? Do you know somebody who has had cancer? My work is important to helping treat people with cancer. Would that have changed the conversation and engaged them? Quite likely. does this mean for you, data scientists, and data scientists that are focused on the use and value of data? Well, like my friend, your work is important. It helps solve problems that matter to humanity. Your data has both use and value. At the same time, it is likely misunderstood, underappreciated, or even dismissed by many. Good communication can change that dynamic. And you need to think about your audience's perspective and interests to gain and keep their attention and support, much as Dawn was mentioning just earlier this morning. So with that, I will talk to you a little bit more about Washington. Your role in providing earth science data and information is important to policymakers in this Washington. Here, we pride ourselves on applying innovation, science, and collaboration to solving problems. It even has a term. People call it the Washington Way. Scientific data and information are an important cornerstone for developing and advancing policy and informing management actions in Washington. And I'll just run through a few examples at a high level. Snowpack data plays an important role in managing water resources for hydropower, agriculture, people, and fish. And unfortunately, you guys probably haven't seen Mount Rainier since you've been here. There is a lovely view of the mountain from Tacoma, I promise. Our weather is not cooperative. Geological and hydrological data is critical to monitoring and understanding the many natural hazards in Washington, such as earthquakes, landslides, volcanoes, and floods. This helps us plan, prepare, and respond in ways that protect people, critical infrastructure, and resources. Many of you know that this is Mount St. Helens, which exploded almost 40 years ago, erupted. And for those of you that have been following the news, we just had a recent earthquake. And these are the many faults that crisscross this region. So this is a very real and important use of earth science data. Weather and atmospheric data helps us manage everything from day-to-day living to current threats to public safety and health, such as managing responses to heat waves, snowstorms, or an active wildfire, such as, the resulting smoke impacts that has. So for those of you that haven't paid attention to the Pacific Northwest much, we've had catastrophic wildfires the last 2 years. And the resulting smoke made our air here the unhealthiest in the world. It was pretty incredible. So this is really critical information for us moving forward. And climate information, as a couple of the speakers this morning have talked about, is critical and requires integrating many sources of earth and ocean data and information. From these observations, we know our climate is changing rapidly. Our local temperatures here have increased about 1.3 degrees Fahrenheit, and we have a decline in snow accumulation and earlier melt-off. Our glaciers are noticeably retreating. We are experiencing more frequent extreme heat, maybe not this week, and the frost-free season has shortened by 35 days. Climate change has serious consequences for people, our public health, our infrastructure and communities, and our natural and working lands. We can use data and information about climate to understand potential future conditions, impacts to people, and the opportunity to change that trajectory with policies that are based in science. And this has been a passion of our governor. And there are groups like the University of Washington Climate Impacts Group that have really worked hard to provide information for policymakers and to help guide that conversation constructively. Governor Inslee's implemented a number of policies that are really aimed at reducing our carbon dioxide emissions, addressing things from our energy to our buildings, to clean cars and transportation. So this is a major passion of his, for those of you that don't know him. So I'll give you a few more examples that are specific to my work. I work on developing and implementing policies that help our state address climate impacts on the ocean. And we know from Earth observations that both the atmosphere and ocean temperatures are warming across the globe due to emissions of greenhouse gases by humans. Globally, the oceans have absorbed more than 90% of this excess heat. That has consequences for us in the Pacific Northwest. In 2015 and 2016, we experienced an extended marine heat wave nicknamed the blob. Ocean observations helped us better understand the scope and scale of the blob. Sea surface temperatures were 2 to 4 degrees Fahrenheit warmer. This warm water combined with upwelled nutrients and triggered massive algal blooms, which lasted longer and spread across much wider areas than observed previously. And in many cases, these blooms produced toxins that were harmful to people and wildlife. And so you can see this is from a National Geographic article about the blob. They did this wonderful graphic that compiled both the sea surface temperature information as well as the chlorophyll data to really combine that information in a way that helps show the interaction between the two. As a result, across the West Coast, we had widespread closures of commercial crab fisheries, shellfish harvests, and the recreational clam fishery. And these are really critical economic and culturally important activities for coastal communities. The crab fishery in Washington represents anywhere from 1/3 to 1/2 of the total landed value for our state. And the razor clam fishery brings about 500,000 razor clam digger trips every year to our outer coast, bringing anywhere from $25 to $40 million of economic activity to these rural communities. Furthermore, we witnessed elevated levels of domoic acid and even poisonings of marine mammals, particularly seals and sea lions. And this was occurring all across the West Coast. So another example is from our state's experience with ocean acidification. As the ocean absorbs carbon dioxide, it alters the chemistry of the ocean, lowering the pH and reducing the availability of key building blocks for marine organisms, particularly shelled organisms. And Washington's especially vulnerable, as is the West Coast, because of upwelling processes that bring additionally high carbon concentrated waters up. And we have here in Puget Sound local land-based sources of nutrients that further exacerbate these conditions. Our shellfish hatcheries were directly affected by ocean acidification, with mass mortalities of baby oysters in shellfish hatcheries about a decade ago. Washington's the #1 producer of farmed clams and oysters in the country. The shellfish industry supports almost 3,000 jobs in our state in mostly rural communities, and they produce about $70 million of labor income every year. So it's a really important industry to our state. There's broader impacts to the marine food web and to other uses that we'll rely on here in the Northwest. And here's some examples of just the pictures of those oysters in normal conditions and then in acidified conditions. So we banded together as a state to address ocean acidification. We developed a comprehensive strategy that was based on scientific knowledge. The actions included additional investments in science, reducing the root causes of ocean acidification, including carbon dioxide reductions and local land-based contributions, and increasing adaptation and resiliency of the communities affected. So how does that relate to data? More specifically, we invested in local monitoring at shellfish hatcheries and the development of a model that can produce short-term forecasts of ocean acidification conditions. What does this do? It allows shellfish farmers to better adjust their operations both within the hatcheries and when they decide to put their shellfish out into the natural environment to better increase the chance of survival of those shellfish. So the Live Ocean model by University of Washington Coastal Modeling Group and led by Parker McCready is the one that's producing these 3-day forecasts. And it's available on our Northwest Association of Networked Ocean Observing Systems, NANOOS. And it relies on a variety of observational data and information to produce those forecasts, from sea surface temperature to currents and chlorophyll. Most regular people you meet on the street wouldn't think that data gathered by satellites and other observational platforms are critical to addressing ocean acidification at this local scale, and yet they are. And when we combine them with other types of observation, they provide the kind of information that can be applied to solving a problem. So, how do we get at the heart of this increasing use and value of data? Many of the speakers this morning have spoken about things that I will touch on as well. This community has done a great job of increasing interoperability and developing different visualizations and tools for access to data. But decision makers and the general public often fail to grasp the importance of Earth observation data. It comes down to a lack of awareness and a lack of appreciation for how this information is relevant to them. If you want to increase the use and value of Earth observation data, you must engage these users. Doing so requires three fundamental things. 1, understanding your audience. 2, communicating with them. And 3, designing accordingly. When you're engaging your audience, that means there's a wide range of potential users of data and information, and that's beyond this room. It's beyond academic researchers and federal agencies. State, local, and tribal governments, specific users such as the shellfish industry in the case of ocean acidification, or even the general public, can use information to solve problems. Understanding your audience involves being a bit of a detective, asking good questions to gather information. Who are they? Why might your data be helpful to addressing their issues, solving their problems, or serving their goals? Why is it relevant to them? What data do they really need? When do they need it, and how frequently? And how do they want to interact with it? You need to talk to them. Metadata standards, cloud platforms, interoperability, those are all really important technical issues that I don't want to dismiss. At the same time, if no one knows your data exists or it is difficult to use, then it is of little use and no value. You need to either identify and communicate with potential users yourself, or make sure you have someone on your team who can do that. You need to find or become a communication ambassador. This will help build awareness of your data and information and the value it might have for them. Find good stories, case studies, and share them, because these provide valuable examples and champions for your data and information. And finally, design accordingly. This is not the field of dreams. You cannot just build it and hope someone will come. You can't just post your data on another data catalog or web map. Often that is not how users are finding and accessing data and information, especially in a policy and management framework. Once you understand your users and talk with them, you'll be able to better understand how to deliver your data and information for their use. This often also helps broaden the support for the platforms and people who make the data and information available. Because the more people are aware of the data and know how it's relevant to them, then they can use it to solve their problems. So the mission and title of this meeting is Increasing the Use and Value of Earth Science Data and Information. You are collecting data that has use and value. And yes, you still need to work on all the nitty-gritty details. But ultimately, to achieve this mission of increasing use and value, you must do more and better. You need to understand your audience, communicate effectively with them, and design data and information products accordingly. It's not easy, but it is important. And if you do that, more people will appreciate and be aware of the data and the valuable role you all play. And ultimately, humanity will benefit from actions that are informed by science. And hopefully, maybe you'll also have better conversations at high school reunions. With that, thank you.
So I would expect that you find yourself interacting with an incredibly diverse number of audiences in the work that you're doing in the governor's office. What strategies do you have for adjusting how you communicate and adjust the message to align with those needs for your audience to understand and appreciate what you're trying to communicate, because that is a continuous challenge that I've certainly found.
Yeah, I think it is. And I think it really is about asking questions and trying to understand where they're coming from and what their interests are. When you do that, you're better able to understand kind of what their goals are, what their mind frame is like, and be able to, as my friend did not with her high school reunion example, sort of change how you talk about the work that you're doing so that it does land in a relevant space. So that's, I think that's ultimately my best strategy.
Thank you.
Thank you for an amazing talk. It's the inspiration of us telling our own story of data is really important. So we represent here quite a number of organizations. I'm from the American Geophysical Union. How can we help you in the governor's office with the story of what you need for the policy change and the culture change and the understanding? How can we give back to you?
That's a great question. I think, we have a crisis of science understanding and appreciation in this nation. And so the more that we can do to help people understand and bridge that, how that information can help make policy and support policy is really important. And it has everything to do with from day-to-day interactions with people that have nothing to do with science. And I think there is this translation issue. Scientists oftentimes want to stay in their safe place where they're publishing their papers. And well, didn't you see that paper? It said some amazing things. Well, there's translation that has to happen for policy makers to be able to use that effectively. And I think scientists need to get comfortable with the fact that there are other factors that come into policy making, not just the science. And so, being there and being able to find people within your community that can translate science. What are the main takeaways? What does it mean for policymakers? That's what they want to know. They don't want to know about this model has these uncertainties and it has these different data streams, and that's why you should support this other little thing. And oh, we need to work on this interoperability problem. They don't care about those things. They want to know what's the take home for the decision they have in front of them. And what is the science telling them about that problem? So it is often challenging for people who work at kind of a much more micro scale to bring it up. And that's why I say, you don't necessarily have to become that person, but you need to find those people that can help be those ambassadors and translators. Great. Thank you.
And I'd like to ask everybody to join me in thanking all of our presenters for their incredibly inspiring presentations, because I think it's the perfect way to sort of energize our groups going into our work for the rest of the day and the rest of the meeting. And Dawn mentioned to me that if the weather gods are not aligned with us actually getting to have a direct view of Mount Rainier, the cover of the GIS and Science book, the illustration is actually of Mount Rainier. So again, you can pick up your free copy over by the registration desk and talk with Dawn and get her to sign the book. I also want to mention that we may have some construction noise from the adjacent building or from next door. So that's just something we're aware of, but we can't do much about. But it is something that may happen. And finally, again, we need to go ahead and clear the room so that the folks in the convention center can go ahead and break it into the spaces we're going to be using for our breakouts for the rest of the day. Thank you all, and go have a great and productive rest of your day.
Hi, everybody. If we could please have you clear the ballroom so we can divide the room for the 10:30 breakouts, we appreciate it. Thank you.